In this video, we're going to use the theorems for parallel lines and transversals to solve problems. The important word in our objective is that word parallel. In our investigation in class, we noticed a difference in which angle pairs were congruent and supplementary when lines were parallel or when lines were not parallel. Now, notice these little arrows on these lines M and N. This indicates in this picture that those lines are parallel to one another. That means that they will never intersect. Now, what we did in class is we compared angles with certain pair names and saw whether or not they were congruent or supplementary. And we saw that several angle pairs were congruent only when lines were parallel, or several angle pairs were only supplementary when lines were parallel. And we have theorems and postulates to represent those relationships. So that first one is called the corresponding angles postulate. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. So like angle 1 is corresponding with angle 5. Notice that those match up exactly. They are congruent. Well, if we have two parallel lines cut by a transversal, also we found out that alternate interior angles were congruent. Our next theorem, if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. Notice I said same side interior theorem. We could have also put same side as consecutive. Remember, those terms are interchangeable. So this could have been the consecutive interior angle theorem. Next we have, if two parallel lines are cut by a transversal, then same side exterior angles are supplementary. So that's our same side exterior angle theorem. So looking at the picture here, angles 2 and 8 are on the same side of that transversal T and outside the two lines M and N. So those are same side exterior angles. Notice that 2 would be congruent to 6. So I could pick 2 up and put it in 6's place. But then 6 and 8 are supplementary to one another. So 2 and 8 must be supplementary. Works the same way here. I know angle 1 is congruent to angle 5 because of the corresponding angles postulate. But notice how 1 and 7 now make a linear pair. Angles 1 and 7 were same side exterior. So that we've shown that same side exterior angles are supplementary. Next, we have alternate exterior angles. So for example, 2 and 7. Or I could pick 1 up. So here's angle 1. I could pick that up, turn it around, and notice that it is the exact same measure as angle 8. Those are alternate exterior angles, and they are congruent. Now, these theorems are going to be really important as we start to prove whether things are congruent or supplementary. It's also really helpful to see the relationships between certain angle pairs. We have one more theorem called the perpendicular transversal theorem. So that says if a line is perpendicular to one of two parallel lines, then it is perpendicular to the second line. Well, because A and B are parallel, and we know that because of these arrows on lines A and B, we also see that M is perpendicular to B because we see this little box to represent that 90-degree angle. So because we know M and B are perpendicular, we then know that we could put a little box here between A and M. We now know that A is perpendicular to M because those lines are parallel and M was already perpendicular to the first one. Now we have some example problems. Name 4 pair of corresponding angles. Now there are more sets of corresponding angles than just 4. But here's an example. We have angles 1 and 8 are corresponding. 2 and 5, 3 and 6, 12 and 16. Notice also that 2 and 9 would be corresponding to one another. They're both in the upper left-hand corner of their sets of angles. They just don't happen to have a transversal that crosses over parallel lines. Now, name for a pair of alternate interior angles. 3 and 8, 4 and 5, 11 and 14, and 12 and 13. If I were to turn this over on its side, we would be interior to S and P, and 1 and 11 would be considered alternate interior angles. R would be the transversal that cut through S and P. Name 4 pair of same-side interior angles. There are some examples there. Same-side interior could be like 8 and 13. It's inside S and P and on the same side of the transversal Q. 4 pair of alternate exterior angles. Okay, so again, we're just naming those angle pairs from this picture. All right, now in number 5, we're actually given an angle measure. We know that angle 1 is 62. Well, remember, we know now that corresponding angles are congruent. So what is corresponding to 1? 1 and 8. So I know that 62 is also the measure of angle 8. Now, I also know that vertical angles are congruent, so I know 1 has to be congruent to 3. But 3 and 6 are corresponding, so I know angle 6 is also 62. Notice that 6 is alternate exterior with 1. Notice that 3 is alternate interior with 8. So notice those relationships and how those are all equal to one another. Now, how would I find angle 2? I know angles 1 and 2 are supplementary because they're a linear pair. So 180 minus 62 would give us 118. And then I know that angle 2 is 118. Angle 4 is vertical with angle 2, so those are congruent. 4 and 7 are corresponding across those parallel lines. And 5 and 4 are alternate interior. 5 is also corresponding with 2. Now notice that angle 1 and 10 are corresponding, but because lines S and P are not parallel, angle 10 is not 62 degrees. Angle 10 tells us that P is already perpendicular to R. So we know that that's 90 degrees. Well, if that's 90 degrees, that means the one that is adjacent to it would also be 90 degrees because they'll be equal to 180. Well, that means the one that's vertical to it will also be 90, and the one that's vertical to 9 will also be 90. But then 10 and 14 are corresponding, so those will be congruent. 16 will be congruent to 12, to all the other ones. Notice when we have perpendicular lines across that set of parallel lines, they're actually all 90 degrees. Then I have question 6. What can be said about line P and line Q? Okay, well, here is line P. Here is line Q. Let me draw that a little better. And P and Q would be perpendicular because of that perpendicular transversal theorem. P and R are already perpendicular, and we were given that R is parallel to Q. So if we know these lines are parallel, and we know P is already perpendicular to R, P has to be perpendicular to Q. All right, your assignment on this is to do questions 1, 2, and 3. So state the postulate or theorem that allows the conclusion that if A is parallel to B, then angle 1 is congruent to angle 2. So state the postulate or theorem that makes sure these are congruent. For number 2, if we know M is parallel to N and segment AC is parallel to segment BD, and the measure of angle 1 is 148, find the measure of all those angles. Then use your angle relationships here to solve for X and Y and Z. Use those theorems with those angle relationships, whether they're going to be congruent or supplementary.